Welcome back, ladies and gentlemen. Let's work through this. So the RB, this is positive RB plus V equals 0, where RB negative equals V. Alright? Sum of forces in the y direction equals 0. Same principle as before. Please watch part 2 and 1 if you do not understand what I'm talking about. Sorry about the background noise, just the fan is on. Alright, so the moments now, M, denoted here. Okay, it's simple. If you just look at the diagram, what is it? M over there. What else is left? RB. Okay. Plus. Sorry. What am I doing? Subtracts. RB, because it's going in the opposite direction, RB, multiplied by 3 minus X, because that's the distance from M to get to RB. Whole thing equals 0. Okay? But M, I'm just going to do this quickly. Alright, so minus 0.4 X plus 1.2. There we go. That's our formula for M. That was our third part. Now we have these formulas. What do we do here? We got the M2, we got the M3, and we got the M1. Now what do we actually do with these guys? Now let's just start pushing them, substituting them, applying them to the diagram. So we start at 0, obviously, and we end up at 0, the target points. So we start at 0. How do we go about this point? Look at the formula. This is our first part we want to work from. The first part tells us M equals, remember what R equals? 3.6x. So 3.6x multiplied by 1. Okay? Which equals 3.6. There we go. Alright, so it goes from 0 to 3.6 because it's multiplied by 1. Alright, let me just, if you don't understand, I'll just quickly show you here. X equals 1 because that's the distance, displacement from 0 to the point we want to be looking at. Where M equals 3.6 kilonewton meters. Alright, so moving on. From here, where do we go? Well, let me show you. Get to the second part. Okay, this was the first part, second part, third part. So simply we go to the second part, substitute from here to this point. Where does it go? So let's just say x equals 2. What happens when x equals 2? This becomes negative 0.8 plus 4, which equals 3.2 kilonewton meters. That tells us that this is going to hit 3.2. Remember, this is all kilonewtons, don't get confused. From here to 3.2. Now, let's go to our part here. What do we do now? Okay. Now, we substitute x equals 2 again. Why? Because this part here is going to have a major influence as to what is going to happen from here onwards. So we want to actually find out what is the influence. We were working out from here and greater than as well. So we have two formulas that can denote one point. Let's see if this is tested true, if this test runs true. Alright, so let's just see where it will go from there onwards. Simple as that. So M equals negative 0.8 plus 1.2 equals 0.4 kilonewtons meters. Remember that a positive distance with respect to this is telling us that it's going to go upwards, but remember this isn't going upwards from here. That formula that we had here, what was this denoted as? This formula here. What was the trick about this? Do you guys remember? This was going from right to left. Right, so that means it goes from right to left. But what's the intersect here? Where do I go? What's happening here? Well, let's go to the diagram. 2,800 Newton meters. Simply just go right up to 2,800 meters. This is 2.8, and it goes up by 4. There you go. Goes up by 0.4. There you go. Done. That's a diagram. Alright, now the actual question asks us, what is the actual point here, the midpoint? Alright, now that midpoint for shear force diagram is simple. It's just negative 0.4 is denoted by the actual diagram itself. That's a constant line. Kilonewtons. Alright, so that's our midpoint. Yeah, but what about our bending moment diagram? What formula do we got to use? Do we have to use 3, 2, or 1? Obviously, 2. So, substitute now x equals 1.5. Alright, that's the halfway distance. Where m equals, so 1.5 into that. Alright, so that's negative 0.63.2. So that's 0.63.4 kilonewton meters. And the answer here is 3.4. The answer is negative 400. There we go, guys. We have completed our tutorial for the bending moments and shear moments, shear force diagram, bending moment diagram, and for the actual beam and forces appliances and moments appliance on an actual beam. Remember, this is static. There is no actual movement of the actual beam itself. There's no movement occurring. There is shear forces applied, there is bending moments applied, however it is static in position, hence from 0 to 0, if you notice here from our diagram, 0 to 0, and when we go up, 0 to 0. Okay, so thank you for watching my tutorial. Sorry about the late uploads. I've just been busy with work and everything. I'll be probably uploading my next video in about 3 days or so. Okay, so thank you for watching. I'll see you guys soon.